If 6 log 2 to the base x, negative 3 log 3 to base x equals 3 log 0.2 to base 5. The question says find the value of x. Now we have a logarithmic equation, so I want to find the value of x. Now to do this, let's start by rewriting the logarithmic equation. So what we're given is 6, so we have 6 the log to the base x of 2 and negative 3 log to the base x of 3 equals 3 log to the base 5 of 0.2. Now the very first thing I'm going to do here is you'd observe that the coefficient of log 2 to the base x is 6. The coefficient here is 3. So 6 and 3, they have a factor common to the two of them, which is 3. So I can factor out the common factor of these two numbers. And since the factor which is common to the two of them is 3, I'm going to write that out. So you have 3. So you'll be left with, so 3 in 6, you have 2, the log of x to the base 2, negative, now 3 in 3 is going to give you 1. And then you have the log of x, or the log of 3 to the base x. So we have this. Now this equals, so this is 3 here, this is 3 the log to the base 5 of 0.2. So now the next thing is I can divide both sides by 3. So when you divide both sides by 3, you divide by 3, so this goes off and this goes off. So what we're going to be left with is you have 2, so this is just going to be 2 the log to the base x of 2 negative, now 1 times this is just going to give you the log to the base x of 3. Now this equals, so 3 has been cancelled out, so you're going to be left with log to the base 5 of 0.2. Now to carry out the next step, I'm going to lay credence to one of the laws of logarithm that says that whenever you have, let's say you have the log say to the base a of m, and then you now have an extra power, so you have p. So now you have 3 things in a row. So what the law of logarithm says is that to balance this logarithmic expression, this is the same thing as, so what you have here now becomes the coefficient here. So in other words, this becomes p and the log to the base a of m. So what the law of logarithm actually says is that these two expressions, they are the same thing. In other words, whenever you have any coefficient of a logarithmic term, so let's say you have the log to the base a of m, now this is just the same thing as just pulling this as a power here. So this becomes the log to the base a of m raised to the power p. So I'm going to lay credence to the information I said here. Now what you have here is you have 2 the log to the base x of 2, so which is similar to what you have here. So it says we can raise this to this power here, so it becomes the power of m. So I'm going to do the same thing here. So this is 2 here, so it says it can become the power of 2, so this becomes the log to the base x of 2 to the power 2. Now negative the log to the base x of 3 equals the log to the base 5 of 0.2. And apparently you know that 2 to the power 2 is going to give you 4, so this is just going to be the log to the base x of 4 and negative the log to the base x of 3 equals the log to the base 5 of 0.2. Also, to carry out the next step, we would also lay credence to another law of logarithm that says that anytime you have the log to the base a of m minus the log to the base a of n. Now this is the same thing as the log to the base a, so they both have log to the base a common to each other, so you write log to the base a, then the division sign you have here is transformed to sorry, the negative sign you have here is transformed to a division sign. So what you're going to have is going to be m divided by n this time around. So this is equivalent to this. So now we have a negative sign here. So that simply tells me that I can transform the logarithmic expression here to what I have here. So this becomes the log to the base x. Now this is 4, so this becomes 4. Then this negative sign becomes a division sign, and then you have 3, so you write 3. So this equals the log to the base 5 of 0.2. So note, our aim is we want to find x. So the thing is that I begin to simplify anything I can simplify just to make my solution clearer. So what I have here is you have the log of 5, or the log of 0.2 to the base 5. Now the thing is that, let me bring this out so we see how I simplify this. So what I have is the log to the base 5 of 0.2. Now this is the same thing as the log to the base 5 of 0.2 is the same thing as 2 divided by 10, and which is equal to the log to the base 5 of 1 over 5, because 2 divided by 10 is 1 over 5, and also we know that the log to the base 5, so 1 over 5 is the same thing as 5 to the power negative 1. So again, we lay credence to the law of logarithm we said here, that said that anytime you have 3 numbers in a row, so the overflow, you can bring it here, so it becomes the coefficient of the logarithmic term. So in other words, I can bring this to this place here, so this becomes -1, then log to the base 5 of 5. So again, the next thing I'm going to do is I'm going to lay credence to another law of logarithm that says that anytime you have, so let me just use a different color so we don't confuse things. So if you have the log to the base a of a, so whenever you have the same base, the number and the same base, when they are the same thing, this is just going to give you 1. So what I have here is the log to the base 5 of 5. So they are the same thing, so since they are the same thing, this goes to 1, and -1 times 1 is just going to give you -1. So in other words, I've been able to show that the log of 0.2 to the base 5 is -1. So I can rewrite my equation as the log to the base x of 4 over 3 equals, so this has been obtained as -1. But then what I have here is a logarithmic equation, and I want to find x. Now to find x, I need to rewrite this equation in a format that will make it very easy for me to find x. So in other words, I need to change the equation in logarithmic form to an exponential form. So what I'm saying in essence is you change. So let me just write that down. So I want to change from logarithmic, so from logarithmic form to exponential form. Exponential form. Now to change an equation in logarithmic form to exponential form, this is just the procedure you carry out. Now whatever you have here, it takes the position of what you have at the right hand side, and whatever you have at the right hand side takes the position of what you have as the original number there. In other words, this becomes x. Now -1 takes the position of 4 over 3, so this becomes -1. Now this equals, so 4 over 3 takes the position of -1, so this becomes 4 all over 3. So you'd observe that when I made the change, the new equation I obtained does not have the log symbol anymore. So this is now an exponential equation. It's exponential because of the exponent you can find here. And x to the power -1 is the same thing as 1 all over x, which is equal to 4 all over 3. So from here you could just cross multiply. So you have 3 equals 4x, and to find x you can just divide both sides by 4. So you have 3 all over 4 equals x. So in other words, our answer is x equals 3 all over 4. So that's the final answer. So let's check if our answer is there. X equals 3 all over 4. Yeah, so here it is. X equals 3 over 4. So that completes the problem.